So today we will discuss a model question paper problem of VTU. So the question runs like this: model question paper. Determine the magnitude and direction of and direction of force F, so that the resultant force is directed along the positive x-axis. And has a magnitude of 1250 Newton Refer the figure. So the figure is given here. So this is the figure. So you have x-axis like this, y-axis like this. So a force has been given like this, F is like this. It is making an angle theta with y-axis, and there is another force 800 Newton acting at an angle of 30 degree with x-axis like this. So this is the point of concurrence. The resultant force, as he says, that it is acting along the positive x-axis. Positive x-axis means like this. So this is the positive x-axis. So according to that, so the resultant force is acting like this, whose value is magnitude is 1250 Newton. The question is, you have to find the magnitude and direction of this force F. So magnitude of F then direction theta. So these two things we have to find out. Of course, this is a case of coplanar concurrent force system, as you know, because the two forces F and 800 Newton, they are meeting at a common point O. So it is coplanar concurrent force system. So point O is the point of concurrence. Now, as usual, we have to resolve the forces. Here the resultant is given, unknown force F has to be found out. So let us resolve the two forces, and we will write sigma Fx and sigma Fy. So if you resolve this force F, so you can see that this can be F cos theta and this will be F sin theta. If you resolve this 800 Newton force, horizontal component will be 800 cos 30, which is acting towards right. Vertical component will be downwards, 800 sin 30, which is acting vertically downwards. Now if you write sigma Fx and sigma Fy, sigma Fx, if you take forces acting towards right positive, that is sign convention, F cos theta is positive, 800 cos 30, it is also positive. So F cos theta plus 800, so this, when this is theta, this becomes cos theta, F cos theta, this becomes F sin theta, because theta is the angle made with the vertical. So this will be 90 minus theta. When this is 90 minus theta, this can be written as F cos 90 minus theta, which is F sin theta only. This will be F sin t minus theta, which sin 90 minus theta, which is F cos theta only. So when the angle is with respect to vertical, so this becomes cos and this becomes sin. So 800 cos 30. So this is with respect to horizontal only, there is no change. So this is the value of sigma Fx. Sigma Fy will be upward positive, downward negative if I assume. So F cos theta will be positive sorry, this is f sin theta. So f cos theta will be positive, but this 800 sin theta will be negative because it is acting downwards. Now he has given that the resultant is acting along the x-axis. So since the resultant is acting along x-axis, so R acts along x-axis means the condition is sigma R, say R is equal to magnitude of R will be sigma fx only, and the value of sigma fy will be 0 because resultant is acting along x-axis. Suppose if they give resultant is acting along y-axis, sigma fy will be R and sigma fx will be 0. Now you have to use these two things now. Let me use this second condition, sigma fy 0. If I use this will be 0. F cos theta minus 800 sin 30 is equal to 0, or f cos theta is equal to 800 sin 30 is nothing but 400 because sin 30 is half. So f cos theta will be 400. Now the second condition is R is equal to sigma fx. So if I use this, R he has given, magnitude of R he has given 1250 Newton is equal to sigma fx is this f sin theta plus 800 cos 30. So if you simplify this, you will get f sin theta is equal to 800 cos 1250 minus 800 cos 30, which becomes 557.2. You can just look it up. 557. Now this is, I call this as equation 1, I call this as equation 2. So there are two unknowns, there are two equations. Whenever you have cos theta and sin theta terms, you can divide one equation by the other to get tan theta. So 2 divided by 1. If I do this, LHS divided by LHS, f sin theta by f cos theta is equal to 557.2 divided by 400. So from this you will get tan theta because f gets cancels. So tan theta is equal to 1.39. From that you get tan inverse of theta is equal to tan inverse of 1.39, which is 54.3 degrees. So the angle theta made by the unknown force F is 54.3 degree. And if you want to find the unknown force F, you can substitute the value of theta either in equation 1 or equation 2. So from equation 1, f cos theta is equal to 400. Therefore, f is equal to 400 divided by cos theta. Theta is 54.3 degree. If you simplify this, you will get 686.14 Newton. So this is the value of magnitude of the unknown force. So in this problem, he has given the resultant. He has asked you to find the unknown force F and its direction. He has given the magnitude and direction of the resultant. So this is a simple problem in coplanar concurrent force system. Now one more problem we will solve. This is also model question paper problem. So as many problems as you work out, so you will get confidence. So this is another problem. Once again, this is PTU model question paper. So the question is like this. He has given system of concurrent forces, x-axis, y-axis, origin. He has given the forces like this. There is a force of 600 Newton acting at an angle of 60 degree vertical in the first quadrant. There is a force of 300 Newton acting at an angle of 30 degree with x-axis in the fourth quadrant. Then in fourth quadrant, one more force is given making an angle 30 degree, that is 100 Newton. Then in second quadrant, he has given 800 Newton making an angle of 20 degrees. In third quadrant, 100 Newton making an angle of 20 degree with vertical. So these are the forces he has given. The question is determine the magnitude and direction of the resultant force. So that we have to find out. So question is determine determine magnitude and direction of resultant force. Position is not required because definitely the resultant force also acts through the point of concurrence. Maybe we have to find out in which quadrant it lies, first, second, third or fourth. So that is based on the values of sigma fx and sigma fy. Now let us do the problem. So it is on similar lines. We have to resolve the forces along x and y directions. We have to find out sigma fx and sigma fy as we did in the earlier problem. Now let us do that. So let us resolve here only. I will tell you how to resolve here only. So here, if you resolve the 600 Newton force, horizontal component will be like this, vertical will be like this. Start from the tail, move towards the tip. So it is like this, both are positive. So since this 60 degrees is with respect to vertical, you can take this as 600 sin cos 60. This can be 600 sin 60. Suppose if 60 degrees with respect to horizontal, then this becomes cos 60, this becomes sin 60. That's how the difference. Now here, this is with respect to horizontal. Therefore, if you resolve this, horizontal component will be like this, vertical will be like this. This is 300 cos 30 only because it is with respect to horizontal. This will be 300 sin 30. Then coming to this. So here also, this is the horizontal component, this is the vertical component. So horizontal component is 100. See, this angle is given with respect to vertical. So therefore, this becomes cos. Please note that. So 100 cos 30, this becomes 100 sin 30. Otherwise, you have to take this as 60 degree with respect to x-axis. 100 cos 60 will be horizontal component. 100 sin 60 will be vertical component. So you know that sin 30 is the same as cos 60 and vice versa. Now coming to this force, here also 20 degree is given with respect to vertical. Therefore, this becomes cos, this becomes sin. So 100 cos 20, this becomes 100 sin 20. Then this one, horizontal component is this, vertical component is this. This is 800 cos 20. This is 800 sin 20. So these are the resolutions, components of all the forces. Now we have to use sigma fx and sigma fy, algebraic sum of all the forces along x direction, treating towards right positive, left negative. So one by one we will take. So this horizontal component 600 sin 60 is positive, 300 cos 30 is also positive. So 600 sin 60 plus 300 cos 30. Then coming to the third force, this is also positive, 100 sin 30, so it is plus 100 sin 30. Then you have this force minus 100 sin 20, minus 100 sin 20. Then you have this force 100 cos 20 negative, minus 100 cos 20. So these are the components, algebraic sum. Now if you simplify this, let us see how much we are going to get. 600 into sin 60 plus 300 into cos 30 plus 100 into sin 30 is of course 50 plus minus 100 into sin 20 minus 100 into cos 20. So you will be getting the value as 600, once again 600 into sin 60 plus 300 into cos 60, sorry, 600 into sin 60 plus 300 into cos 30 plus 100 into sin 30 is 50. Then you have minus 100 sin 20, that is minus 100 into sin 20 minus 100 into cos 20. So the value you are going to get is 701.25. 701.25 Newton. Since you have got positive value, sigma fx is acting towards right. Suppose if you get negative value, it would have been acted towards left. Oh, sorry, this is 800. 800. See, 600 into sin 60 plus 300 into cos 30 plus 50 minus 100 into sin 20 minus 800 into cos 20. 43.47. Yes. 43.47 Newton. So you should be careful when you are writing. Yes, next sigma Fy. Upward forces positive, downward negative. Once again, you take vertical components. 600 cos 60 is positive, upwards. Then you have 300 sin 30 negative, downwards. 300 sin 30. Then you have 100 cos 20 negative, 100 cos 30 is also negative. So minus 100 cos 30 minus 100 cos 20. Then you have plus 800 sin 20. So these are the algebraic sum of vertical components. Now let us calculate this. 600 into cos 60 minus 330 sin 30 is 150 minus 100 into cos 30 minus 100 into cos 20 plus 800 into sin 20. So the value you get is 243.04. That is also positive. 243.04 Newton. Positive means it is upwards. Now once you get the magnitude and directions of the sigma fx and sigma fy components, you can just show the resultant direction. So sigma fx is positive, sigma fy is also positive. So therefore the resultant will be acting in the first quadrant. This is R, and the angle made by the resultant with the horizontal x-axis is alpha. Now let us find out R. Sigma fx square plus sigma fy square under root. That is 43.47 square plus 243.04 square under root. So if you simplify that, you will be getting the value as 246.9 newtons. 246.9 newtons. That is the magnitude of resultant. Direction of resultant alpha is given by tan inverse of modulus sigma fy by sigma fx, which is tan inverse of 243.04 divided by 43.47. So this you are going to get 243.07 divided by 243.04 divided by 43.47 tan inverse of that. So 79.86 degrees. 79.86 degrees. So this is the direction. Now once you find out the magnitude and direction of the resultant, and once you know the quadrant in which that resultant acts, so then you can represent it like this: x-axis, y-axis, origin. So this is how the resultant force acts. The magnitude of this resultant is 246.9 Newton, and the angle made by the resultant in the positive anti-clockwise direction of x-axis is theta, that is alpha, that is 79.86. This is the answer. So whatever may be the number of forces they give in the coplanar concurrent force system, only magnitude and direction of the resultant is required. Position is not required because the resultant also passes through the point of concurrence, which is in this case it is the origin. So only magnitude we have to find out using this formula, direction we have to find out using this formula. Then depending on the directions of sigma fx and sigma fy, we can get in which quadrant the resultant lies.